Before there were galaxies, there was darkness. Not the kind that hides behind stars or fills the spaces between them, but a total, unbroken silence. Then, against the odds, light appeared. Not from galaxies or clusters or nebulae, but from something older, lonelier, and more primal. The first stars. It sounds impossible. How could stars exist before the galaxies that were meant to cradle them? Yet this is the riddle the cosmos leaves us, that perhaps, long before structure, there was brilliance. To answer it, we must go back, far beyond the Milky Way, beyond every spiral and cluster, to a time when the universe was barely awake. A few 100 million years after the Big Bang, the cosmic fog began to thin. Hydrogen, the simplest element, gathered under gravity's whisper. And in that gathering, something extraordinary happened. Matter ignited. That moment, known as the cosmic dawn, was when darkness ended and history began. The first light pierced eternity, announcing that creation had found its voice. But what was it like when the universe saw its first sunrise? To find out, we must travel to the age before galaxies, when space itself was still learning to glow. In the beginning, the universe was radiant, not with light, but with heat. 1,000,000,000,000 suns worth of energy compressed into a single, blinding instant. Then, in less than a heartbeat, it began to cool. Expansion tore everything apart. Space itself stretched faster than light, carrying with it a storm of energy, matter, and chaos. When the Big Bang faded into silence, there was no explosion lingering in the void, only the aftermath, a newborn cosmos gasping in the dark. For a brief moment, light still roamed freely. Photons collided with a dense sea of particles, protons, electrons, and neutrons trapped in an endless fog. Every attempt at illumination was instantly scattered, absorbed, and released again, like 1,000,000,000 mirrors reflecting nothing. The universe was brilliant, but blind. Then, as expansion continued, the fog thinned. Temperatures dropped to a few 1,000 degrees, cool enough for electrons to bind with protons. Hydrogen and helium atoms, the first elements, were born. This era, known as recombination, was the universe's first breath of stability. And with that breath, the lights went out. Photons, finally freed from constant collisions, streamed into the void. They stretched with the universe's expansion, losing energy, fading into microwaves. Billions of years later, that ancient radiation would reach us as the cosmic microwave background, the universe's oldest memory. But to the cosmos itself, it marked the beginning of silence. The fire had dimmed. The age of light was over before it had even begun. For the first time, the universe was dark. It would remain that way for a very long time. A cosmic night lasting more than 100 million years. Imagine it. An endless ocean of hydrogen and helium expanding in every direction, featureless and still. No stars, no galaxies, no points of reference, only drifting gas, cooling atom by atom, as gravity began its patient, invisible work. This was the Dark Age, a time when nothing shone, yet everything was becoming. Gravity, weak yet relentless, began to tug at the tiniest imperfections left behind by the Big Bang. In that early fireball, matter wasn't distributed evenly. Some regions were slightly denser than others, no more than 1 part in 100,000. Yet those minute differences were destiny. Over millions of years, those faintly denser regions began to pull in their surroundings, grain by grain, atom by atom. Invisible structures began to take form. Not yet stars, not yet galaxies, but the silent scaffolding of creation. Space, once smooth, began to ripple. Matter flowed into invisible wells, gathering like dew in the dimness. The universe, though blind, was already dreaming of light. But time in this newborn cosmos moved slowly. Everything was immense, and everything was far apart. Imagine clouds of hydrogen spanning light years, drifting without sound or heat. In those clouds, collisions were rare. It would take millions of years for gravity to draw enough matter together for anything to happen. The cosmos was expanding faster than its contents could gather, a race between creation and dispersal. And yet, the laws of nature were patient. Gravity never hurried. It simply waited, pulling ever so slightly more matter into each growing clump. Within those clumps, pressure began to build. Invisible, inaudible, but inevitable. The first whispers of stars forming, though the universe was not yet ready to ignite. If one could have watched this epic unfold, there would be nothing to see, but much to feel. The universe was like an immense black ocean, its surface perfectly still. Beneath that calm, unseen currents twisted and swirled. Density waves from the Big Bang rippled through space, compressing gas here, thinning it there, like the slow breathing of a slumbering giant. These ripples were the seeds of everything that would ever exist. The faint blueprint of galaxies, etched into the darkness long before any light appeared to reveal them. For 100 million years, this vast emptiness persisted. It was a cosmos of potential, waiting to awaken. And yet, this waiting wasn't meaningless. It was preparation, the quiet before the first dawn. If we could drift through that time, what would we witness? Not stars or planets or color, but the texture of silence itself. Every atom, every photon, every quantum field, suspended in delicate equilibrium. The temperature hovered just a few dozen degrees above absolute zero, the universe's heartbeat slowing to an ancient rhythm. And within that stillness, faint patterns began to form, threads of invisible matter weaving through space, guided by something we could not see. Dark matter. Dark matter was the silent architect of the cosmos. Though it neither emitted nor absorbed light, its gravity shaped everything around it. It gathered ordinary matter, the hydrogen and helium that filled the void, into vast filaments stretching across the universe. These filaments connected into a web, a structure so enormous that even today, billions of years later, galaxies trace its pattern like dew upon a spider's threads. But in those first moments, there were no galaxies to illuminate this web, only the promise of them. The tension of this era was profound. Every pull of gravity was countered by expansion. The universe itself was stretching faster than its contents could collapse. Would anything ever ignite? Would light ever return? Or would the cosmos expand forever, cold and blind, a perfect symmetry never broken? Something unseen was stirring in the dark. In the densest knots of gas, where dark matter's pull was strongest, hydrogen atoms began to collide. Slowly at first, then more often as the clouds thickened. Every collision released a whisper of heat. Pressure mounted. Gravity pressed inward, and the gas resisted, its temperature rising. In those regions, invisible embers were forming, the precursors to the first stars. But these protostars were fragile. A slight disturbance could tear them apart before they ever burned. The balance between collapse and stability was razor-thin. The universe seemed to hesitate, as if holding its breath. Then, somewhere, we do not know exactly where, gravity won. A single cloud of hydrogen collapsed faster than it could cool. Deep within its heart, the pressure grew unbearable. The atoms crushed together, fused, and in that instant, light returned. The first star had been born. Its brilliance shattered the darkness of 100 million years. For the first time since the Big Bang, the universe had a source of light that wasn't fading, a flame burning against infinity. But that moment still lay ahead. For now, in the Dark Age, the stage was being set. The ripples of destiny were already spreading, each one marking a place where, someday, a star would shine. It's difficult to imagine a time without light. Our minds are wired to picture stars, to navigate by brightness, to define existence by visibility. But in this early universe, sight itself would have been meaningless. There was no up, no down, no distance. Only density and void, expansion and pull. The physics of this time were simple, yet profound. The universe was cooling, from billions of degrees to mere hundreds, then tens. Hydrogen atoms absorbed and emitted faint radio signals, a spectral fingerprint still detectable today by astronomers as the 21-centimeter line. This faint emission allows us to map the darkness itself, to listen to an age before vision existed. Those signals tell us that the Dark Age wasn't uniform. It was a landscape of subtle variation, a map of future light. Where the density was higher, stars would form sooner. Where it was lower, darkness would linger longer. The first structures of the cosmos were not sculpted in light, but in gravity's invisible geometry. Philosophically, this era carries an eerie resonance. It reminds us that creation does not begin in brilliance. It begins in waiting. Every form, every atom, every star that would ever exist first endured the silence. It's as if the universe had to learn patience before it could learn to shine. If we think of time as a story, then the Dark Age was its preface. Wordless, motionless, yet full of promise. The silence wasn't empty. It was potential compressed into stillness. And when we study that ancient quiet, we aren't just looking at physics. we're witnessing the universe's first act of becoming. Even today, the faint afterglow of that silence surrounds us. The cosmic microwave background stretching across the sky is not light from stars, but from the universe's infancy, a ghostly echo of the moment when everything became transparent. It is the first visible relic of the cosmos, a map not of what was seen, but of what was about to see. The age of darkness may have lasted 100 million years, but its importance is eternal. Without that stillness, there could be no structure. Without that waiting, no awakening. Every galaxy, every world, every human eye that would one day gaze at the stars, all of it was born from that long night when the universe was blind. In the end, the darkness was not the opposite of creation. It was its cradle, and though the first light has long since faded, the memory of that silence remains, written into the fabric of space itself. Every photon that travels now carries a trace of that beginning, the echo of the moment before illumination. The universe was not empty. It was listening. Something unseen was stirring in the dark, and soon the night would end. In the silence after creation, the universe began to move. Not with noise or light, but with collapse, a slow gathering of invisible will. Gravity, patient and tireless, had been sculpting the darkness for hundreds of millions of years. Now at last, the waiting was over. The cold hydrogen clouds that drifted through the void began to fall in upon themselves, tightening like clenched fists in the fabric of space. The age of stillness was ending. The universe was about to learn how to shine. It began quietly. Within each dark matter, halo, those invisible wells of gravity that cradled ordinary matter. Gas accumulated until the pressure could no longer be contained. As the hydrogen atoms crowded closer together, they began to move faster, colliding and heating, transforming emptiness into energy. In one hidden corner of the cosmos, deep inside a collapsing cloud, temperatures reached millions of degrees. And in that furnace, something extraordinary happened. Hydrogen nuclei fused. Two atoms became one. In the heart of the first star, the first light since the dawn of time was born. These were not stars as we know them. They were giants, titans made of purity itself. Astronomers call them population 3 stars, the first generation, forged entirely from hydrogen and helium. There were no metals, no carbon, no oxygen, no dust to cool them down or fragment their birthplaces. They grew enormous, some hundreds of times more massive than our sun, burning with a ferocity the cosmos had never seen. Their light was blue-white, searing, relentless, and their lives were brief. In the blink of cosmic time, they lived, shone, and died. The first stars were the universe's great improvisation, its first attempt at complexity. Without heavier elements to stabilize their cores, they burned through their fuel with reckless speed. A star of 200 solar masses might have lived for just 2 or 3 million years, a heartbeat compared to the sun's 10 billion. But in that short existence, they accomplished something miraculous. Through the pressure and fusion in their hearts, they forged the first heavy elements: carbon, nitrogen, oxygen, iron, elements that would later build worlds, oceans, and life itself. Creation, it turns out, began with destruction. When these first stars died, they did not fade quietly. Their deaths were cataclysmic. Many ended as supernovae so powerful they outshone entire galaxies, though galaxies at that time barely existed. In those brief flashes, the universe was illuminated from within. The darkness was split by fire, and space itself trembled under the force of rebirth. The explosion of a massive star is both an ending and a beginning. Its outer layers are hurled into space, carrying with them the heavy elements created in its core. The surrounding gas clouds absorb this material, mixing it with hydrogen and helium. These enriched clouds will eventually collapse again, forming the next generation of stars, ones capable of forming planets, chemistry, and perhaps consciousness. The death of one gave birth to the potential of millions. They died so everything else could live. For a universe still young, this was a turning point. The first light did not merely illuminate space, it transformed it. The radiation from these stars ionized the surrounding hydrogen, tearing electrons from atoms and creating bubbles of transparency in the fog of the early cosmos. These pockets of light slowly expanded, merging and spreading until the universe was once again visible. The long night of cosmic darkness was ending, replaced by an era of radiant dawn. Simulations allow us to peer into this ancient epoch, the cosmic nurseries where the first stars were born. Computer models show gas streaming along the filaments of dark matter, falling into knots and forming compact clusters. In these pockets, the temperature and density rise, birthing not one star, but dozens. The process is chaotic and beautiful. Stars forming, exploding, and enriching their surroundings in a cosmic dance of destruction and renewal. The universe was learning to recycle itself. Each supernova seeded its neighborhood with metals, astronomers' term for all elements heavier than helium. And these metals allowed subsequent generations of stars to cool and fragment, producing smaller, longer-lived suns. This feedback loop, birth, death, enrichment, is the heartbeat of cosmic evolution. The cosmos was no longer static. It was self-creating. Yet there's an irony buried deep in this first light. The very brilliance that illuminated the cosmos also began to erase the conditions that made it possible. As the first stars flooded their surroundings with ultraviolet radiation, they heated and ionized the gas, preventing new stars from forming nearby. The light that revealed the universe also began to reshape and restrain it. In the act of creating, the universe learned limitation. For every flame, a shadow. If one could stand, impossibly, near a population 3 star, the experience would defy comprehension. Its surface temperature would reach tens of thousands of degrees, its radiation lethal to any molecule. Its light would travel for billions of years, spreading across expanding space until, eons later, it might strike the mirrors of a telescope on a small blue planet, orbiting a distant descendant of its ashes. The photons that first broke the cosmic silence could still be arriving now, faint whispers from the dawn of everything. There's something profoundly human in that thought, that we, creatures of carbon and oxygen, owe our existence to stars that lived before galaxies, before worlds, before anything solid or lasting. They did not live long enough to be remembered, but everything that came after them remembers them in its atoms. Every breath of air, every drop of water, Every cell in your body carries the legacy of those first stellar deaths. The carbon that structures your DNA was born in their cores. The iron in your blood once pulsed in the heart of a giant that burned before galaxies formed. We are not separate from that beginning. We are its continuation. The light they released did not merely illuminate space. It became the chemistry of life. Light, in that sense, is knowledge, the universe's way of knowing itself. When the first stars ignited, they weren't just burning fuel. They were transforming ignorance into awareness. Before them, there was only potential. After them, there was history. A cosmos that could be seen, measured, and remembered. The act of shining was an act of self-recognition, but even this recognition came with a cost. The first stars, in their magnificence, were unstable. Many were so massive that their cores collapsed directly into black holes, swallowing their own light in the same instant it was born. In these collapses, the seeds of supermassive black holes may have been planted. Those titans that would later anchor galaxies and shape their evolution. From destruction, order. From chaos, structure. In this paradox lies the secret rhythm of the universe. To create, something must be lost. The first stars burned not to last, but to change. They existed only to make everything else possible, and so the Dark Age gave way to illumination. The universe blossomed with pockets of light, isolated clusters of stars flickering against the void. Each cluster was a proto-galaxy, bound loosely by gravity and glowing with the fire of newborn suns. The first structures of meaning appeared, light connected to light, star to star, in constellations too vast for human eyes. This was the universe's adolescence, raw, explosive, and restless. Everywhere matter was learning to organize itself, to find balance between gravity's pull and radiation's push. The interplay between collapse and release became the symphony of creation. Astronomers studying this era see echoes of it in the most distant galaxies observed today. Faint, smudges of light billions of light years away, their photons stretched by cosmic expansion until they whisper across time. Instruments like the James Webb Space Telescope can peer into that ancient light, revealing galaxies that formed just a few 100 million years after the Big Bang. But even Webb may not see the first stars themselves. They were too small, too brief, too isolated. Their legacy survives not in their light, but in everything that followed. When we observe the universe now, we see a masterpiece painted on a canvas of darkness. Galaxies spiraling, stars pulsing, nebulae glowing. Yet all of it began with a handful of giants that flared and died in obscurity. Their ashes became the paint, their explosions, the brushstrokes. They were the spark behind every sunrise, the ancestor of every dream. And though their lives were measured in moments, their influence endures forever. The universe is, in a sense, the memory of those who first dared to shine. When matter learned to shine, the cosmos crossed a threshold. It became visible, not just in light, but in meaning. The interplay between gravity and fusion, between collapse and illumination, mirrored the tension between ignorance and understanding. It is as if the universe itself discovered curiosity, the desire to illuminate what was once hidden. Creation, it seems, is not a steady process, but a cycle of ignition and extinction. The first stars lived fast and died violently, but in their deaths they created the possibility for calm, for stars like the Sun, for galaxies like the Milky Way, for worlds where awareness could one day ask how it all began. When we look into the night sky, we are not seeing light, we are seeing memory. Every star is a fossil of that first act of creation, a descendant of those ancient flames that burned alone in the void. The photons that strike your eyes tonight carry within them the same code of transformation. Energy into matter, matter into meaning. The first stars were not just physical events. They were metaphors written into reality. The universe discovering that it could make something greater than itself, that destruction could be beautiful, that impermanence could create eternity. They did not last long, but they changed everything. In their final moments, as they exploded or collapsed, they gave the cosmos its future, a universe of diversity, of chemistry, of possibility. The age of darkness was over. The first light had not only illuminated the universe, it had transformed it forever. The cosmos had learned the most profound truth of all, that to exist is to burn, to fade, and to give back the light you were given. And so, from the ashes of the first stars, the galaxies began to gather, drawn together by the gravity of what had been lost, and what was still to come. Before galaxies existed, they were already being shaped by gravity's memory. Long before any spiral arms unfurled, before the cosmic web glowed with starlight, the invisible scaffolding of the universe was already at work. The darkness itself was carving out a future, not through light, but through pull. Gravity, that patient sculptor of everything, was weaving the first pattern of order into the chaos left by the Big Bang. The aftermath of the first stars had changed everything. When they died, they left behind shock waves that rippled through the surrounding gas, compressing some regions while dispersing others. The universe was still dark in most places, but it was no longer uniform. The ashes of the first stars had seeded the void with metals, cooling agents that allowed new clouds of gas to collapse more efficiently. Gravity seized its opportunity. In the densest knots of the cosmic web, clusters of stars began to gather, the raw embryos of the first galaxies. These were not the elegant spirals or smooth ellipticals we see today. They were chaotic, irregular, and violent. Clouds of gas crashed together, igniting bursts of star formation. Supernovae detonated like fireworks, stirring turbulence through the fragile clusters. And through it all, dark matter provided the invisible foundation. Dark matter, that elusive, unseen mass making up roughly 85% of all matter in the universe, was the silent architect behind every galaxy. It does not emit or absorb light, but its gravity binds the visible universe into shape. In the earliest times, it gathered into halos, vast, roughly spherical envelopes where normal matter could collect. These halos were not solid or static. They were living gravitational wells, merging and growing as the universe expanded. Inside these halos, hydrogen and helium gas began to cool and sink toward the center, drawn deeper by gravity's pull. As the gas condensed, it fragmented into clouds, and within those clouds, new generations of stars ignited. Each newborn cluster lit up the surrounding darkness for the first time, forming small glowing islands of light inside the invisible sea of dark matter. It was a delicate process, a competition between creation and destruction. When stars formed, they flooded their surroundings with energy, heating and pushing the gas away. Yet gravity continued to draw it back. The early universe was a restless battlefield between collapse and expansion, between light and shadow. Out of that tension, the first galactic structures began to emerge. Imagine looking across the young cosmos, a vast darkness punctuated by tiny, flickering embers. Each faint spark marked a newborn star cluster nestled inside a dark matter halo. Some were so dim that even our most powerful telescopes today can barely detect them. But together, they formed the universe's first communities. Stars no longer adrift and alone, but bound by shared gravity, orbiting within invisible cocoons. These clusters collided, merged, and tore one another apart. The universe was small then, denser, more crowded. Collisions were inevitable. When two halos merged, their contents blended chaotically, stirring gas into new storms of star formation. The process repeated endlessly, as small halos combined into larger ones, and those into larger still. Through these violent unions, the first galaxies were born, not as grand creations, but as survivors of cosmic chaos. It's easy to think of galaxies as built, like cities, planned, structured, deliberate. But they were not built, they were woven. Gravity was the loom, dark matter the thread, and light the pattern that would one day reveal itself. In this young universe, galaxies were not isolated islands. They formed along vast filaments of dark matter that stretched for millions of light years, connecting one region of space to another. Gas flowed along these filaments like rivers, feeding the growing galaxies at their intersections. Over time, these intersections, the nodes of the cosmic web, became the cradles of the largest structures in the cosmos. Galaxy clusters, superclusters, and the great walls of galaxies that define the universe's architecture today. Yet the early galaxies were fragile. Their gravity was weak, their stars few, and their shapes unstable. The radiation from newly formed stars and black holes threatened to strip away the gas that fueled them. Supernova explosions blew holes in their disks, tearing apart the very material they needed to grow. It was a time of trial, a universe learning through chaos. But even in that turbulence, order began to emerge. The galaxies that survived were those that balanced violence with stability. Some grew massive enough that their gravity could hold onto gas even after repeated explosions. Others merged, their orbits stabilizing into rotating disks. Slowly, spirals began to appear. Faint, imperfect, but recognizable. These were the ancestors of galaxies like our Milky Way, spinning gently amid the debris of 1,000 collisions. Before long, the first true structures of the cosmos could be seen. Proto-galaxies, compact and irregular, glimmered faintly, their light stretched and reddened by the expansion of space. They were still small, perhaps 1,000th the size of modern galaxies, but they burned with intensity. Star formation rates were enormous, with new stars being born faster than at any other time in cosmic history. For the first billion years, the universe was ablaze with creation, and yet something strange still lingered. Even as galaxies took shape, stars were still forming outside them, isolated in intergalactic space, adrift in filaments and clouds too diffuse to be captured. Astronomers call these orphan stars, relics of failed galaxies or fragments stripped by collisions. They wander the void between galaxies, glowing faintly, reminders that the cosmos was never perfectly ordered. Even in the age of galaxies, chaos had not fully surrendered. Simulations of this era reveal a universe that looks less like a collection of objects and more like a living organism. Streams of matter flowed toward dense knots, while shock waves and winds ripple outward. Every merger sends waves of energy and motion through the surrounding space. From a distance, it resembles a vast network pulsing with life, a cosmic neural web connecting every point of light. Dark matter remains at the center of it all, guiding the dance. Though invisible, it dictates how galaxies spin, how they grow, and how they cluster together. Without it, stars would fly apart. Galaxies would never hold. Its gravitational influence extends far beyond the visible boundaries of galaxies, shaping the unseen geometry of the universe. We live within those invisible hands, every motion of our galaxy following a pattern written in dark matter's pull. As billions of years passed, the galaxies evolved. The smaller, irregular systems merged into larger, more complex forms. Collisions between gas-rich galaxies ignited spectacular bursts of star formation, galactic fireworks lighting the sky. When the chaos settled, new shapes emerged. Smooth, elliptical galaxies where stars moved in random orbits, and graceful spirals where rotation imposed order. The modern cosmos was beginning to take shape. The Milky Way itself is the descendant of countless mergers. Our galaxy carries within it the bones of ancient collisions, streams of stars left behind by smaller galaxies that were absorbed over time. The halo of the Milky Way still holds these remnants, ghosts of the universe's earliest structures. In every galactic core, history is layered like sediment, stars from one epoch woven into the fabric of another. From a philosophical view, this transformation, from chaos to coherence, from scattered stars to galaxies, reflects the universe's deepest principle. That order is not imposed, but emerges. Gravity doesn't dictate design. It nurtures it. The galaxies were never commanded into being. They found themselves, born from the balance between energy and entropy, between creation and collapse. Even now, when we look at the night sky, we see that balance frozen in beauty. Spiral arms curve gracefully. Dust lanes trace symmetry through turbulence, and ancient ellipticals glow with the light of 1,000,000,000,000 quiet suns. Yet beneath that serenity lies the memory of violence, of collisions, chaos, and destruction. Order was not the opposite of chaos. It was its consequence. The galaxies we admire today, majestic, structured, and serene, are survivors of billions of years of turmoil. Their shapes are the outcome of gravitational compromise, their light the residue of ancient fires. Every spiral arm, every cluster, every filament of starlight is a record of endurance. Astronomers using powerful telescopes like Hubble and Webb can now see faint glimmers of these first galaxies. Some are so distant that their light has traveled for more than 13 billion years, stretched by cosmic expansion into infrared wavelengths. These ghostly forms are small, red, and irregular, yet they contain the blueprint of everything that followed. When we look at them, we are seeing time itself. the moment order first began to emerge from the abyss. To the human mind, galaxies may seem eternal, ancient monuments suspended in space. But in cosmic terms, they are still young, still evolving. Collisions continue even today. Galaxies merge and reshape, their stars mingling like currents in a vast ocean. In a few billion years, our own Milky Way will collide with Andromeda, forming a new, larger elliptical galaxy. A continuation of the same process that began nearly 14 billion years ago. Every structure, no matter how grand, traces its ancestry back to those first gatherings of matter in the dark. The galaxies are not separate creations. They are expressions of a single unfolding process. They were not built in isolation. They were woven from the same cosmic threads that stretch across the entire universe. Before galaxies existed, gravity had already written their story. The universe was merely waiting for light to read it. From the first clusters of stars to the majestic spirals we see now, one truth endures. The cosmos seeks coherence. Out of chaos comes pattern, out of darkness comes light. And out of countless collisions comes the quiet grace of structure. Galaxies are not merely collections of stars. They are the memory of creation itself. Lanterns in an infinite fog, carrying the echo of the first dawn. And though they appear still and eternal, they are always becoming, always reweaving the fabric of the universe, one collision at a time. Some of the first stars may have been truly alone, drifting in the dark, far from any galaxy, unanchored to anything but gravity's faint memory. Before the cosmic web fully formed, before the first galaxies tightened into shape, there were wanderers. They shone briefly, like sparks leaping from an unseen fire, and then vanished into the night, their light traveling through eternity with no home to return to. These were the orphans of the early universe, stars without homes. It sounds impossible. We imagine stars as members of families, galaxies filled with billions of them, bound together in swirling arms or elliptical clusters. But what if the first stars existed before any such order emerged? What if creation began not in community, but in solitude? The James Webb Space Telescope has begun to test this idea, peering deeper into time than any instrument before it. What it sees is astonishing. Among the faintest, most ancient light in the universe are isolated points. Lone flickers with no visible galactic structure around them. They are so distant that their light has been stretched into the infrared, carrying messages from more than 13 billion years ago. Some appear to exist outside any recognizable galaxy, adrift between faint clumps of matter. They may be remnants of early star clusters that never grew into galaxies, or perhaps survivors of primordial explosions, flung into intergalactic space. To understand them, we must go back to the first billion years, when the cosmos was still sorting itself out. The dark matter halos that would later form galaxies were assembling through mergers, but not all gas fell into these growing wells. Some regions, slightly denser than others, collapsed independently, too small to form full galaxies, yet massive enough to give birth to stars. These were microcosmic laboratories of creation, fragments of gravity's web where light was born in isolation. Simulations of the early universe reveal this beautifully. When scientists model the distribution of dark matter and baryonic gas, they find not one seamless structure, but countless small condensations, filaments, and knots scattered across the void. Some of these knots, containing just a few million solar masses of gas, could have cooled and ignited without ever joining a larger system. The stars they formed would live short, brilliant lives before exploding and dispersing their matter into space. No galaxy would remain to remember them, no cluster to hold their light. Yet their deaths would still shape everything that came after. Light existed before order. It's a humbling thought. That illumination does not require belonging. These rogue stars, shining alone in the cosmic dark, were proof that the universe could create beauty before it could create structure. They were not part of anything larger, yet they were the seeds from which all structure would eventually grow. Many of these isolated stars were likely massive, perhaps even more so than those within the first galaxies. Without the stabilizing influence of surrounding gas or nearby companions, their formation was wild and unrestrained. Gravity collapsed entire pockets of hydrogen into single enormous stars hundreds of times heavier than the Sun. Their light was fierce, their lifespans short. They burned themselves out in just a few million years, leaving behind black holes or supernova remnants that drifted through space. Astronomers now believe that some of these early orphans could have planted the first black holes in intergalactic space, seeds that would later migrate into forming galaxies, growing into the supermassive giants we see at galactic centers today. If so, the universe's most powerful objects began as wanderers. In JWST's deep field images, there are hints of this wandering past. Among the faint smears of proto-galaxies are stars so bright they stand out even against cosmic distance, gravitationally lensed by intervening matter, magnified just enough for us to see them. One such object, nicknamed Arundel, may be a single star from less than 1 billion years after the Big Bang. It shines with the brightness of 1 million suns, yet exists at a time when galaxies were barely formed. Its name means morning star, fitting for a light that bridges the cosmic dawn and the long night before it. But for every visible orphan, countless others remain invisible. The majority of early rogue stars likely lived and died unseen, their light swallowed by the expanding fabric of the cosmos. Their radiation helped ionize the intergalactic medium, turning darkness into transparency. But their stories were lost. The universe does not archive its early chapters in light. It records them in consequences. Philosophically, these solitary stars pose a question as haunting as it is beautiful. Can creation exist without connection? We often think of the cosmos as a web of relationships, galaxies orbiting clusters, stars orbiting galactic centers, planets orbiting stars. But before all of that, there were only individuals, self-contained bursts of existence, alone yet radiant, isolated yet essential. Their loneliness was not emptiness, it was genesis. In that solitude, the universe experimented. Each rogue star was a note in the first composition of creation, a melody played across unimaginable distances. Their isolation was not a flaw, but a necessity, a prelude to structure. Without those early acts of singular creation, there could be no galaxies to gather them later. Astronomers studying rogue stars today find them even in our modern universe. High-velocity stars have been discovered speeding through intergalactic space, flung from their home galaxies by gravitational encounters, or supernova explosions. Some travel millions of kilometers per hour, escaping forever into the void. These wanderers echo the first orphans, reminders that even now, stars can be born into connection and end in isolation. If we could stand beside one of those primordial outcasts, floating alone between galaxies, what would we see? Around us, only the faintest glow, the cosmic microwave background stretched and dimmed by time. The nearest light source might be millions of light years away, yet the star itself would burn furiously, its radiation cutting through the silence, defiant against infinity. It would be a single voice in a universe without language, a flame refusing to acknowledge its solitude. Such stars challenge our assumptions about belonging. We seek patterns, systems, families. But the cosmos began without them. The first light did not need a galaxy to define it. It existed because it could, because the laws of physics allowed it, because gravity and chance conspired in one small corner of the void to make something luminous. Even in its earliest form, the universe seemed to understand a paradox we still wrestle with: that isolation can be the birthplace of connection. Each rogue star enriched the space around it, scattering heavier elements that would later help galaxies form. Their solitude laid the groundwork for togetherness. In dying alone, they ensured that everything else could live together. Light without structure, creation without company. It's difficult not to see the reflection of this in ourselves. We, too, are born from isolation, individual consciousnesses emerging from a vast cosmic field of matter and memory. Each life burns alone, yet contributes to something larger. Each thought, each act of curiosity, adds a photon to the universe's ongoing illumination. Perhaps those first stars were not truly alone after all. Their light traveled outward, intersecting with the glow of others across the cosmos. Even before galaxies existed, the universe was already connected, not by structure, but by light itself. Each photon was a bridge, each ray a thread, weaving meaning into the void. As time passed, gravity gathered those scattered lights into clusters and galaxies, giving form to what was once only connection through radiation. The orphans found their descendants in stars bound by shared motion and common origin. The universe had transitioned from solitude to community, from scattered sparks to cosmic cities. But somewhere, deep in intergalactic space, some of those first wanderers may still be drifting, cooling embers that never found a home. Their light, long gone, still moves through us. Every particle in our bodies was once free-floating matter, wandering through the cosmos before being bound into structure. We are, in a sense, the children of orphans, assembled from the debris of solitary stars that dared to shine. When we look at the night sky, we see galaxies, patterns, constellations, but hidden among them are solitary points, rogue stars between galaxies, barely visible, reminders of a time before belonging. They are the universe's quiet testimony that creation does not wait for permission, and that even in the absence of order, light finds a way. If stars came first, before galaxies, what does that say about us? That perhaps meaning, like light, begins in isolation, and only later discovers structure. That perhaps we do not belong to the universe. We are the universe's way of belonging to itself. In the end, The rogue stars teach us that the first act of creation was not togetherness, but courage, the courage to burn alone in the dark, knowing that someday that light would guide others home. Before light, even time had no witness. The universe existed, but nothing could see it. For hundreds of millions of years, space had been filled with invisible forms, gas clouds drifting in silence, gravity sculpting the unseen, creation waiting to be known. Then suddenly, everything changed. The first stars and galaxies ignited, flooding the cosmos with radiation. Darkness retreated, and in that retreat, the universe became visible for the first time. This was the cosmic dawn, the awakening of light, and perhaps the first moment the universe could truly perceive itself. The transformation was neither simple nor sudden. It unfolded over hundreds of millions of years in a process astronomers call the epoch of reionization. To understand what that means, we must recall what came before. After the Big Bang, as the universe expanded and cooled, protons and electrons combined to form neutral hydrogen atoms. This made the cosmos opaque, not because it was filled with darkness, but because its gas absorbed and scattered any light that tried to pass through. The universe was wrapped in fog, a veil of invisibility. Only when the first stars formed did that veil begin to burn away. Their ultraviolet radiation rionized the hydrogen around them, tearing electrons free once again and turning the universe transparent. The first light didn't just illuminate space. It made seeing possible. Each new star, each infant galaxy, carved a small bubble of clarity in the surrounding darkness. At first, these bubbles were isolated, glowing islands in a sea of fog. But as more stars were born, their light expanded these regions until they began to overlap. Gradually, the entire universe underwent a phase transition, from opaque to clear, from hidden to revealed. It was not just the dawn of light, but the birth of vision. Astronomers today study this ancient awakening through relics that still echo across space. The cosmic microwave background, the faint afterglow of the Big Bang, shows us the universe before the first stars. But to see what came next, we look to instruments like the James Webb Space Telescope and the Planck satellite, which trace the faintest signals of that great transition. The radiation from the first galaxies, stretched and red-shifted by billions of years of expansion, reaches us as a soft whisper in the infrared. Webb has revealed galaxies that existed just 300 million years after the Big Bang. Their light arriving now, across a gulf of 13 billion years. Each pixel in those images is a fossil of illumination, a record of the universe's first attempt to see itself. But what was it like, that first dawn? Imagine standing, impossibly, in the early cosmos. Around you stretches a sea of neutral hydrogen, opaque and quiet. Then, far away, a point of light flares to life. A young, massive star burning at unimaginable temperatures. Its photons rush outward, colliding with hydrogen atoms, breaking them apart, creating a growing sphere of transparency. Soon another star ignites, then another, until the night itself begins to change. The fog dissolves, and for the first time, light travels freely across space. The universe breathes in clarity, and yet this awakening came at a cost. The first dawn was also a death, the death of the dark age that birthed it. The silence that had once cradled potential was gone, replaced by the noise of energy, radiation, and motion. The universe had crossed a threshold. It could no longer return to innocence. In the same way that consciousness once emerged from the stillness of life, the cosmos itself had become aware, filled with witnesses to its own unfolding. From a scientific view, the epoch of ionization was a grand experiment in transformation. The ultraviolet radiation from young stars, black holes, and galaxies ionized nearly every atom of hydrogen in the universe. This changed not only the transparency of space, but its temperature, chemistry, and structure. It allowed light to travel unhindered, but it also erased evidence of what came before. The Dark Age's perfect symmetry was gone, replaced by complexity. By contrast, from a philosophical view, it was the birth of perception. Before this time, the universe could be said to exist without being known. Nothing could look upon it. Nothing could remember it. But with light came observation, and with observation came meaning. The cosmos had, in a sense, opened its eyes. When we look at the night sky today, we are gazing into that awakening, the remnants of the universe learning to see. The galaxies we observe through telescopes are not just ancient structures. They are neurons in a vast cosmic brain, firing for the first time. Each spark of starlight represents a thought. Energy becoming awareness. Darkness becoming comprehension. The same physics that transformed the early universe mirrors the processes within us. Matter organizing into light. Light into consciousness. This is no coincidence. The principles that allowed the cosmos to become visible, feedback, interaction, illumination, are the same that govern the emergence of mind. When radiation filled the universe, it began a chain reaction of self-reference. Light revealed matter. Matter shaped light. Each became aware of the other's existence. In that interplay, reality acquired texture. The epoch of ionization is, in many ways, the universe's first act of introspection. It was not enough for stars to burn. Their light had to travel, to interact, to reveal. The fog of neutrality had to be lifted before the cosmos could recognize its own form. When we measure that light now, using satellites and telescopes, we are participating in that same act. Light studying light, consciousness analyzing its own origins. The observer and the observed are one continuous process, separated only by time. But there are limits to how far we can look. No telescope, not even Webb, can see beyond the wall of ionization. The light from before that era is trapped, absorbed by the hydrogen that once filled the universe. This is the cosmic horizon, the edge of sight itself. Beyond it, we can only imagine what the universe looked like before it became visible. It is both a boundary of observation and a reminder of mystery, a veil that light itself cannot yet lift. This barrier has profound implications. It tells us that there is a point in time we can never directly witness. The moment when the universe was awakening but not yet awake, when the first flickers of light existed but could not yet be seen. That invisible dawn is not just a scientific frontier, it is a philosophical one. It marks the threshold between being and knowing, between existence and awareness. The more we study this epoch, the more it feels like the story of perception itself. At first, there was confusion, overlapping regions of light and dark, visibility and blindness. Then, as the process spread, coherence emerged. The universe transitioned from fog to clarity, from silence to song. It learned to sustain illumination, to remember. In a human mind, this would be the instant thought begins. The first neuron fires, the first awareness dawns. And like the universe, the brain requires contrast between dark and light, potential and action to function. Consciousness, too, is an act of reionization, the clearing of mental fog, the moment awareness begins to illuminate itself. When astronomers study the ancient light of the cosmic dawn, they are not just reconstructing physical history. They are glimpsing the first echo of that universal awakening. The photons we capture in our detectors were emitted when matter first learned to shine and space first learned to see. Each one carries a fragment of that transition, a message from the moment the universe became visible to itself. There is a strange poetry in this. The light that made the universe transparent has spent billions of years traveling through that same space, only to be absorbed again, this time by the retina of a conscious observer. In that act, the circle closes. The cosmos that once learned to see is now seen by the consciousness it created. The cosmic dawn, then, is not just a chapter in cosmology. It is the first awakening, a mirror of the human story. Out of the fog of unconsciousness, light found form. Out of expansion came perspective. Out of solitude came reflection. The universe's first light was not merely a phenomenon. It was an act of understanding written in photons. And yet, this awakening was also fleeting. The fog lifted, but new mysteries arose, galaxies forming, stars dying, black holes growing. The clarity of the cosmic dawn was not a conclusion, but a beginning. The light that made seeing possible would also reveal how much there was left unseen. The first dawn was a death. Yes, the death of the quiet that had nurtured creation. But it was also a birth of sight, of memory, of consciousness. The darkness that once filled the cosmos was not destroyed. It became the contrast that made illumination meaningful. Every star, every atom, every thought since has been a continuation of that first act. The universe remembering itself through light. We look back now through telescopes and equations, trying to glimpse the moment it all began. But perhaps the truth is simpler and closer. The cosmic dawn never really ended. It lives on in us, in every act of perception, in every spark of curiosity, in every eye that opens to the night sky and wonders what it's looking at. For when light first filled the cosmos, it didn't just reveal space. It revealed the possibility of understanding. It was the moment the universe woke up and began, at last, to see itself. You are made of the first stars, the universe remembering its beginning. Every atom in your body, every thought that flickers across your mind, every breath of air you take, all of it traces back to the moment when the cosmos first learned how to burn. The calcium in your bones was forged in ancient fire. The iron in your blood was born in the heart of a dying giant. You are not separate from that origin. You are its continuation. After the first stars blazed and died, their ashes did not fade into nothingness. They scattered across the cosmos, seeding the dark with possibility. Supernovae, explosions so powerful they outshone galaxies, tore through the surrounding gas, enriching it with heavy elements. Those elements, carbon, oxygen, nitrogen, iron, became the raw material for everything that followed: planets, oceans, life. The universe was no longer a place of pure hydrogen and helium. It had matured. The first stars had changed not just the scenery of the cosmos, but its very chemistry. This transformation was the beginning of the cosmic web, not just the physical structure of galaxies and clusters, but the chain of causality linking every part of existence. As the enriched gas drifted through space, gravity gathered it into new clouds, birthing the next generations of stars. These later stars were smaller, longer-lived, more stable. Around them, disks of gas condensed into planets. On one of those planets, billions of years later, consciousness would awaken, a distant echo of the same physics that once ignited hydrogen in the void. The first stars did not live long, but their influence was eternal. Their deaths set off a cascade of creation that continues to this day. When they exploded, they generated shock waves that compressed nearby gas, triggering new waves of star formation. They also helped shape the intergalactic medium, heating and ionizing it, pushing and pulling matter in patterns that would become the scaffolding of galaxies. Each generation of stars built upon the ashes of the last, forming a cosmic lineage written in light and dust. And yet, among those ashes, something else was born, something darker, denser, and far more enduring. Some of the first massive stars collapsed entirely, their cores crushed by gravity into black holes. These were not small remnants. They were seeds of enormity, primordial black holes that would grow into the supermassive titans anchoring galaxies today. From destruction came stability. The very centers of galaxies formed around these invisible hearts. The Milky Way itself orbits such a core, a black hole millions of times the mass of the Sun, the quiet remnant of ancient fire. The cosmic web, the vast network of filaments stretching across the universe, owes its existence to these intertwined processes. Dark matter provided the scaffolding, but baryonic matter, the normal stuff of stars and gas, filled in the details. Where dark matter gathered, galaxies formed. Where stars lived and died, heavy elements spread. The universe became a living tapestry, each thread glowing with the energy of creation and destruction, expansion and collapse. The physics behind this is beautiful in its simplicity. Gravity pulls matter together. Fusion releases energy. Death disperses matter outward again. This endless cycle of gathering and scattering is the heartbeat of the cosmos. It is both mechanical and sacred, a rhythm that began with the first stars and continues in every atom that vibrates within us. Over billions of years, feedback loops shaped the cosmic landscape. When massive stars exploded, they heated their surroundings, preventing nearby gas from cooling too quickly and forming new stars. But as the debris expanded and cooled, that same material later collapsed into fresh star-forming regions. Light both destroyed and preserved creation. A cosmic balance between radiation and gravity, chaos and order. Through this push and pull, the universe found equilibrium. The remnants of those first stars still echo through everything we see. Astronomers can detect their fingerprints in the faint glow of ancient galaxies and in the chemical signatures of the oldest surviving stars, fossils from the earliest epochs. These second-generation stars contain traces of the heavy elements forged by their ancestors, like ink written into their light. By studying them, we read the story of how the universe learned to build complexity from simplicity. And it's not just cosmic history, it's personal. The same process that turned hydrogen into carbon is the one that turned dust into us. The connection between stellar death and human life is not metaphorical. It's literal chemistry. Every atom of oxygen you inhale was once inside a star. Every photon that enters your eyes is the same kind of light that once broke the universe's first darkness. When you look at the night sky, you are not looking at something other than yourself. You are seeing the mirror of your own origin. We are galaxies that learn to look back at their ancestors. When we study the stars, we are not just gazing outward, we are gazing backward, through time, through memory, through the evolution of being itself. The telescopes we build, the equations we write, the stories we tell, all of them are the universe's way of continuing its first act of seeing. Light that traveled billions of years now converges on a human eye, completing a circuit of awareness that began at the dawn of everything. If we were to visualize this cosmic lineage, it would resemble a vast web, not just of matter, but of meaning. Each node, each galaxy, each star connects to countless others through gravitational threads. The death of one feeds the birth of another. Even the voids between filaments are not empty. They are fields of potential, waiting for new cycles of creation to begin. The web is not static, it is alive, vibrating with the same laws that govern our hearts and minds. In cosmology, scientists use simulations to trace this structure. Massive computations model billions of years of evolution, showing how dark matter filaments draw gas into threads, how galaxies form at intersections, how black holes ignite at their centers. The result is breathtaking. A cosmic network that looks uncannily like the neural map of a human brain. The scale differs by a factor of trillions, but the pattern, the rhythm of connection, is the same. The universe, it seems, thinks in structure. From this perspective, the line between science and philosophy blurs. The same physical laws that shaped galaxies also shaped life. The same fusion reactions that powered the first stars now fuel our sun, sustaining every organism on Earth. The cosmic web is not just out there. It is within us, pulsing in every breath, every heartbeat, every spark of thought. There's a profound humility in recognizing this. We are not observers standing apart from the universe. We are participants in its unfolding. The atoms in our hands are older than the Earth. The light in our eyes is the same energy that once burned through hydrogen in the first stellar cores. To exist is to continue that ancient story, to carry forward the memory of the cosmos in living form. But even as we marvel at this connection, we must remember its fragility. The same processes that create also destroy. Stars are born and die. Galaxies merge and vanish. Even the cosmic web itself will one day thin, stretched by expansion until the filaments dissolve into cold isolation. Entropy waits, patient and inevitable. Yet in that inevitability lies meaning, because the beauty of the universe is not in its permanence, but in its continuity. The light that fades becomes the seed of something new. The cycle never truly ends, it only transforms, and so, the story of the first stars is also our story. Their explosions made our blood possible. Their gravity shaped our galaxies. Their light paved the way for our sight. When they burned, they began a chain of consequence that would eventually ask, through us, what it all meant. The universe has spent billions of years arranging atoms into awareness, just so it could wonder where it came from. We are that wondering. Every human question, every scientific discovery, every moment of awe is a continuation of the first light learning to see itself. The cosmic web is not only physical, it is conscious. Each mind, each life, each fleeting moment of understanding adds another thread to the grand tapestry of existence. You are made of the first stars. Their ashes became your atoms. Their light became your thoughts. And when you look up at the night sky, you are not looking into distance. You are looking into memory. You are the cosmos recalling itself, the embodiment of a universe that once burned in solitude and now burns through awareness. In the end, the cosmic web is not just a structure of galaxies. It is a story of connection, from the first spark to the human heart, from the birth of light to the birth of meaning. The universe began as matter, became light, and through us became memory. Every atom, every photon, every heartbeat is part of the same web, the web of everything. The first stars didn't form before galaxies. They were the galaxies, dreaming themselves into existence. Their light didn't wait for structure. It became structure. Their deaths didn't end creation. They scattered it, setting the pattern that would echo across all of time. The universe never paused between beginnings. It unfolded in one continuous act of illumination, from the first photon to the first thought. When we look back across billions of years, we tend to separate things: the birth of stars, the rise of galaxies, the emergence of life. But the truth is simpler and more profound. There was never a moment when the cosmos was divided between darkness and order. The darkness was order, sleeping. The light was life, awakening. The first stars and the first galaxies were two sides of the same revelation. The universe learning what it was capable of. That revelation has never stopped. Every new galaxy that forms, every atom that bonds, every eye that opens, all are extensions of that first moment. The same light that tore through the hydrogen fog of the early cosmos now streams through our own perception. When you look at the stars, you are witnessing light that once burned to make seeing possible. And when you feel wonder, that is the same reaction the universe had when it first realized it could shine. The light never went out. It only changed form. It became oceans and forests, moons and minds. It became the spark in your neurons, the warmth on your skin, the flicker of curiosity that refuses to die. We call it consciousness, but it is really just illumination turned inward, light aware of its own existence. Somewhere in the long evolution from atoms to awareness, the cosmos learned to remember itself. Perhaps memory is what the universe has been building toward all along. From the death of the first stars came the elements that would one day compose the brain capable of contemplating them. From explosions came empathy. From fusion came thought. The same forces that shaped galaxies now shape questions. And every question we ask, about the beginning, about our place, about what comes after, sends ripples through the same field of being that once carried starlight. We are not looking into the universe. We are the universe looking back. There is no real separation between the first dawn and this one. The photons that began their journey 13 billion years ago are still traveling, still illuminating, still touching new eyes and new minds. In that sense, the first light never stopped moving. It simply found new ways to be seen. We are one of those ways. Our awareness is the continuation of that journey. The cosmos, made conscious. If you could watch the entire history of the universe unfold in a single glance, you'd see a simple rhythm. Light arising, spreading, fading, and arising again. It is the same rhythm that governs breath, thought, and life itself. Creation and dissolution. Discovery and forgetting. Explosion and calm. All woven into one pulse. The galaxies are not frozen monuments. They are living memories, carrying within them the residue of that first act of brilliance. The first light did not ask for permission to exist. It appeared because it could, because possibility itself longed to be seen. And that impulse has never faded. It flows through everything, from the birth of stars to the act of imagination. The same energy that once illuminated the void now writes poems, builds telescopes, and wonders what it means to exist. Maybe that is what the universe has been doing all along, transforming energy into awareness, until at last it could look upon itself and ask, "Where did I come from?" In that moment, the circle closed. The first light became the last question. The universe began the moment light appeared, and it has never truly stopped beginning. Each discovery, each act of seeing, is another dawn. We carry that first sunrise within us, not as metaphor, but as matter. Every photon that fills your vision tonight is an echo of the same awakening that began it all. So when you look into the darkness of the night sky, remember, you are not looking into emptiness. You're looking into origin. The galaxies are not far away. They are the universe's reflections of your own awareness, mirrored across time. The stars that died for you to exist are still burning in the atoms of your body. The light that once traveled through eternity now lives behind your eyes. Perhaps the first light never went out. It only became us. And when we wonder, when we pause, even for a breath to feel awe, the universe remembers itself once more. The same silence that came before the first dawn still waits between our thoughts, holding the glow that began everything. In that silence, the story of creation continues, not as an ending, but as remembrance. The light that once broke the darkness of the early universe still shines, quietly, through every act of awareness. The light that remembered.